Hey everyone, welcome back to the channel. Today we're super excited to present the brand new version 1.30 of AutoCodeAgent, a revolutionary AI agent that's about to transform how you handle complex tasks. Imagine an intelligent agent that doesn't just execute code, it smartly breaks down intricate tasks into a series of bite-sized executable Python functions. With AutoCodeAgent, your challenges become a sequence of manageable subtasks, each dynamically handled with precision. Think of it as your very own Swiss Army knife for AI, loaded with a wide array of powerful tools and features. One of the coolest aspects of AutoCodeAgent is its modular design. Whether you just need to plug in a library or add custom code snippets with detailed instructions, the integration is seamless and adaptable to your needs. This flexibility empowers you to expand its capabilities effortlessly, making it a standout solution in the world of AI-driven automation. Download the repository, the link is in the description. Run it with Docker following the instructions in the readme.md file and test its functionality. If you like it, leave a star and contribute with a fork, pull request, issue, or feedback. And if you are a programmer, come on, let's collaborate together to make an innovative project grow. Let's dive into what's new in version 1.30. One of the standout upgrades is the integration of Langchain's Toolbox. Now you can access over 130 powerful tools simply by specifying the tool name. Imagine that. This enhancement means you can effortlessly tap into an extensive list of functionalities to streamline and supercharge your workflows. And if you're curious to explore all these tools in depth, just head over to the Langchain Tools documentation for a full rundown. Now, let's dive into a live demonstration of AutoCodeAgent in action. Watch as it breaks down a complex task, creating a TV host who presents weather forecasts, using the powerful tools provided by Langchain. Over the next few minutes, you'll witness firsthand how AutoCodeAgent dynamically decomposes this task and seamlessly integrates various functionalities. Stay tuned, because after the demo, we'll dive into a detailed code analysis to show you exactly how the Langchain integration was implemented.
Good evening, Rome. Tonight, we have a delightful weather forecast for the Eternal City. The skies are expected to be clear and brilliant.
Stasera vi presentiamo un aggiornamento meteo dettagliato per la città eterna. Il cielo sarà prevalentemente sereno, con una luminosità che permetterà alle stelle di brillare intensamente durante la notte. Le temperature si manterranno in...
Quelques nuages sporadiques pourraient apparaître, mais ils n'altèrent.
Now I will walk you through the code and explain what happens under the hood for Langchain Toolbox integration. Let's walk through the inner loop that processes each tool in our list. For every tool, we first check if its type is marked as a Langchain tool. If it is, we extract the Langchain tool name and any additional parameters provided. The code then calls the load tools function from the Langchain community toolkit, passing the tool name and these parameters. If the tool loads successfully, we take the first instance from the returned list and pass it along with its name and parameters to the Langchain tool converter from Langchain tool method. This converter method is responsible for transforming the native Langchain tool into our standardized tool schema. If no tool is loaded, or if any exception occurs during this process, an error is logged to help with debugging. Now let's dive into the Langchain tool converter class. Its main job is to take a Langchain tool instance and convert it into a dictionary that matches our default tool schema. Inside the static method from a Langchain dog tool, the converter first extracts the tool's name using Python's getattr, ensuring a default value of unknown doc tool if it's not available, and then converts this name to lowercase. It also fetches the tool's description, which becomes the instructions for the tool. The converter then checks whether the tool has an args attribute, which should be a dictionary containing the expected inputs. If present, it iterates over these inputs, copying each entry while ensuring that each input has a description, defaulting to no description provided if not, and removing any extraneous information like a title. The tool's output type is similarly extracted, defaulting to string when not specified. After processing the basic attributes, the converter prefixes the tool name with a specific identifier to clearly denote it as a Langchain tool within our system. One of the most valuable features of this class is the automatic generation of a code example through the GenerateCodeExample method. This method converts the additional parameters into a formatted string of keyword arguments, and it builds an inline comment section detailing each expected input with its description. It then constructs a Python function as a string that demonstrates how to load the tool with load tools, build the tool input dynamically, run the tool, and capture its output. This code snippet, complete with error handling and comments, provides developers with a ready-made template to understand and integrate the tool. Ultimately, the from Langchain tool method returns a dictionary containing the standardized tool name, a list of library names, indicating where the tool was loaded from, the instructions, a flag that instructs the system to use the code example exactly as provided, and the generated code example itself. This design not only abstracts the complexities of integrating Langchain tools into a unified schema, but also enhances developer productivity by offering clear, executable examples and robust error handling.